One of the easiest way to graph a function is really by picking points, by selecting points. So for example, if I say graph the function, first the word function, let me just go back for why we call function. Normally we have y equals, let's say like this, 2x plus 3. We go, is this a function? And to answer the question, to be a function, you have to satisfy one condition, and that is for any x value, there is one and only one y value. That's what a function is. If you can prove for every x value or for any x value there is one and only one y value, you have a function. So for example, is this a function? The graph of this, is this a function? Yes. Why? Because if you pick any x value, like this one, there's only one y value to it. If you pick this x value, how many y values to it? 1. Do you remember how we used to test to see if you have a function when you have the graph? Yes. Absolutely. The vertical line test. You draw vertical lines. If any of these lines intersect the graph at more than one point, it's not a function. So this is a function. What's not a function is this one. This is not a function. Because if I do the vertical line test, notice this line has how many intersection? 2. This is not a function. And again, the reason that's not a function, because this x value now has two y values. It has this one, it has that one. Now, why we like the word function? Because now instead of y equals 2x plus 3, I'm always full of energy, so if I'm going fast, let me know. If I have y equals 2x plus 3, instead of saying y, I'm going to use f because the word function begins with the letter f. I'm also going to let you know the variable on the right, I'm using the variable x. So instead of y, I'm going to use f of x. And the nice thing about that notation, because I can ask you what is f of 0. And when you see that, that says replace x with what? With 0 in the f function, because you might have more than one function, or the f expression. So f of 0 here becomes 2 times 0 plus the 3. What's 2 times 0? 0 plus 3, which is what? 3. What is f of negative 5? Replace x with what? Negative 5. 2 times a negative 5 plus the 3. 2 times a negative 5, which is what? Negative 10 plus 3, which is negative 7. What is f of x plus h? Sit down here. How do we find f of x plus h? You replace x with what? X plus h. So we had, this will be 2 times x plus h plus the 3. You're replacing x with x plus h. Distribute that. That will give me what? 2x plus 2h plus the 3. Again, the reason I talked about function, because when you graph, one of the best way to graph, or one of the easiest way, is by picking points. I wouldn't say the best, but one of the easiest way to graph a function is by picking points. So if somebody said to me, graph y equals 2x plus 3, the way I'm going to graph it, I'm going to make a chart or table here. Pick values for x. It doesn't matter what values I use. It won't change anything. And find the y value. So I might pick a 0, like you saw in that example we just did. A negative 2. A 3. A 5. I can pick any values I want to pick. Now that doesn't mean go crazy, start picking 2004, 1,397,000. You'll need a paper the size of Texas. Not lately, because the paper will be wet with all the water they got there, poor people. What's 2 times 0? 0 plus 3? 3. When x is negative 2, what's 2 times a negative 2? Minus 4 plus the 3? Negative 1. When x is 3, what's 2 times 3? 6. 6 plus 3? 9. When x is 5, 2 times 5? 10. 10 plus 3? 13. And now, if you have a graph paper, we'll pretend we have a graph paper. 0 and 3 is right here. Negative 1 and negative 2 is right here. 3 and 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 is right there. 4, 5 and 13, 10, 11, 12, 13, 14, 15. And when you plot these points, connect them, it's going to be a straight line going through them. And that's the graph of y equals 2x plus 3. We can always graph any function by picking points, but if it's not a straight line, you got to pick a lot of points. You'll find out later in life when we cover derivatives and application of that, maybe picking points is not the best way to graph them. Because if you just pick points, you might miss some of the fun stuff there. Let's see what I'm talking about here. Let's say we ask you to graph y equals, let's say x cubed minus 4x. And I say graph this one. And I go, let me pick values for x. I'm trying to find the y value that matches. Let me try a negative 2, negative 1, 0, 1, and 2. Now, if I don't do the minus 1 and the 1 here, if I decide just to do minus 2, 0, and 2, let me leave these blank for now. If I don't choose these two values here, I might be really in trouble there. Because when x is a negative 2, what are you going to have? What is negative 2 cubed? Negative 8. This is plus 8 because negative 4 times, here we go. I'll just do them here so you get to see them. That'll be negative 2 cubed minus 4 times a negative 2, which is what? Negative 8 plus 8, which is 0. when you choose the 0, this is 0 cubed minus 4 times 0. 0 minus 0, which is what? 0. When it's 2, it's 2 cubed minus 4 times 2. That's 8 minus 8, which is what? 0. So when you, oh, I can graph this. That's a straight line. 0, 0, 0, 0. It looks to you like a straight line. So I said picking points is not the best way, but if we pick more points, we'll notice it's not really a straight line. Like if I add the minus 1 back here and the 1 and put them back in, what about the minus 1? This is negative 1 cubed minus 4 times the negative 1. That's a negative 1 plus 4, which is what? 3. So it says, oh, that's 1, 2, oh, it's right there. What's f of 1? It's 1 cubed minus 4 times 1, which is negative 3. So if you try to connect them with straight line, we got a problem. You got to find out the graph of this really looks something like this. If you pick more points, so if we end up picking like some values in between, plenty more points, we'll get that graph. So that's the draw to graphing really by picking points. If you have a problem like this, you got to pick a lot of points to get the actual picture. This point, by the way, has a name. Anyone knows what that point is called here? So is this point. So is that point. X-intercept, correct. This has 3x intercept. That's where the function intersects the x-axis. How do you, I should ask, what is the y value at these 3 points? Can you tell me what the y value is for all 3 of them? 0. So how do you find the x-intercept? You make y 0. This point also happens to be also what? The y-intercept. That's where the graph intercepts the y-axis. And at the y-intercept, what's the x value equal to? 0. So in some cases, people a lot of times want to find the x and the y-intercept because they want to find out where does the function intersect the y-axis? Where does the function intersect the x-axis? So to find the x and the y-intercept, let's see if I can get that. This problem, y equals the same one we just did. To find the x-intercept for that, if you want to know where the function intersects the x-axis and the y-intercept, here we have actually more than one. Just in case we have more than one. I know we only have one. This we have 3 here. To find the x-intercept, you let y equals to 0. And to find the y-intercept, you let x equals to 0. That's how you find your intercept. So the y-intercept, the x-intercept, you let y be 0. You have 0 equals x cubed minus 4x. How do you solve this one? Remember how we solve it? We factor. What do they have in common? The greatest common factor is what? X. You can take an x out. What's left? X squared minus 4. Can I factor x squared minus 4? X minus 2, x plus 2. And you want to multiply these three things. We call them factors, by the way. You want to multiply these three factors and get an answer of 0. The only way that will happen if what? If one of them is 0, or two of them 0, or all three zeros. So if one of them is 0, so take each one, set it equal to 0, and solve it. And I use, to solve this, I'm going to take the minus 2 to the right side, and I use change side, change sign. When I take them to that side, I'm going to change the side. So we have three answers. The x-intercept, we have a 0, at 2, and at minus 2. Let me look at my picture. 0, 2, and minus 2. How do you find the y-intercept? You let x be 0. So if you let x be 0, what do you have? Y equals to 0. So if you want to write these as a point, that's 0, comma 0. That's 1 point. Negative 2, comma 0, another one. And 2, comma 0. That's your x-intercept. Your y-intercept is what? 0, comma 0. And that's the quickest way to find the x and the y-intercept. The x-intercept, you let y be 0. The y-intercept, you let x be 0, and solve it. Again, we're bouncing all over because it's supposed to be a review of all pre-calc there. We're going to try to cover a whole course in about 2 classes. So, symmetry of a graph. So, let's talk about 3 types of symmetry. One is symmetry or symmetric. We'll go symmetric instead of symmetry. It's the same thing. Symmetric with respect to the y-axis. If you know your function is symmetric with respect to the y-axis, the nice thing about knowing that, if you know the graph on the right side looks like this, how do we get what the graph on the left side is going to be? Take that paper and fold it along which axis? The y-axis. So the other half will look like this. So you don't have to pick points on the left side and on the right side. You can just do one side and flip it over. That's the nice thing about knowing if the function is symmetric with respect to the y-axis. Well, how do you know the function is symmetric with respect to the y-axis? Well, you know it's symmetric with respect to the y-axis if f of negative x equals f of x. Meaning, if you replace x with the negative x, you end up with the same answer. An example, f of x equals x squared minus 4. What is f of negative x? Replace x with negative x. Which ends up being what? X squared minus 4. Is this the same? They are the same. So is this symmetric with respect to the y-axis? Yes. By the way, when the function is symmetric with respect to the y-axis, that's called even function. I don't know if our book talks about that or not. So that's an even function. We have an even function. Which means if I graph that, I only have to graph 1/2 of it. I'll just pick some points on the right side. When x is 0, what's the y value? Negative 4. When x is 1, what's 1 squared? 1 minus 4 is negative 3. When x is 2, what's 2 squared? 4. 4 minus 4, 0. When x is 3, what's 3 squared? 9 minus 4 is 5. I know the graph on this side looks like this. Since that's an even function, all I got to do, flip that paper over. Now I know what the other half looks like. So I don't have to pick points on both sides of the y-axis. Only one side. Knowing it's an even function, just flip it over. So that's called an even function. It could be symmetric with respect to the x-axis. That's the second one. That might look like this. If one side looks like this here, then the other side, since symmetric with respect to the x-axis, will look like this. This was called even function. What do you think this one's called? Odd function? Try again. It's not a function. Vertical line test. Well, it's not the inverse yet. Inverse will actually draw a line like this, 45 degree. So this is really not a function. So it doesn't have a name. We don't call it even or odd function, this one, because it's not a function. But how do you know you have symmetric, or the graph is symmetric with respect to the x-axis? If you replace y with negative y, and your expression doesn't change. If you replace y with negative y and get the same expression, that's symmetric with respect to the x-axis. I could have this one, x equals y squared minus y to the 4th. Now if I replace y with negative y, what are you going to have? X equals negative y squared minus negative y to the 4th. And when you square a negative sign, that's a plus. And notice these two are the same. So this is symmetric with respect to x-axis. So all I got to do, graph one half of it, pick values for y, pick some positive values for y and see what the graph looks like, then flip it over and you have your answer. So if I want to graph this, I'm going to pick the y value. This is x versus y. I'm going to pick y. So I'll use a 0, a 1, a 2, a 3, a 4. Maybe I got too many here. And once I know what the graph that looks like, I'll flip it over and I have the other side. When y is 0, what is 0 squared? 0 minus 0 to the 4th, that's 0. Bless you. When y is 1, 1 squared is 1 minus 1 to the 4th, that's a 1, that's 0. When y is 2, that's 4. 4 minus what? About 16, right? 2 to the 4th, 16. So 4 minus 16, which is what? Negative 12. Forget about the 3, it's too big. So far, this is what I see. 0, 0 is here. 0 and 1 is here. Negative 12 and 2 is right here. I should pick the value maybe between the 0 and the 1 just to see what's going on. Is it going like this? Because it could be the graph like this, you know. So let me pick a value between the 0 and the 1. How about a half? I'm not going to do the 3 and the 4. That's too far. So if I use the half here, what is 1/2 squared? 1/4 minus, what's 1/2 to the 4th, which is what? 1/16. To subtract these two, you're going to need the LCD, which is 16. That's 4 minus 1, which is 3 over 16. So somewhere here, actually. 3/16 and 1/2. So my graph looks like this. Since I know the graph is symmetric with respect to the x-axis, what's the other half is going to look like? A McDonald's sign, somebody tipped it sideways. And that's not a function. So that's how you know if the function is, well, it's not a function, if the expression is symmetric with respect to the x-axis. And the other one, symmetric with respect to the origin. By the way, that's called an odd function. An odd function. And if we know the graph on this end looks like this, now to find what the other picture is, you got to do it in 2 steps. I don't have the imagination. So I do it in 2 steps. I go, well, if I flip it over, the x-axis will look like this. And take that image now, flip it over the y-axis, it will look like this. So it's 2 flips. Flip it over the x first, then flip that image over the y. Or you can do the reverse. You can flip this over the x first, which will look like this, then flip it over the y. So it doesn't matter which one you do first. And to see if your function is symmetric with respect to the origin, you replace x with negative x and replace y with negative y. If you end up with the same expression, you have an odd function, or a function that's symmetric with respect to the origin. Let's take this one. Y equals 2x cubed minus x. Is this symmetric with respect to the origin? Replace x with negative x. Replace y with negative y. If you end up with the same expression, the answer is yes. Here's the negative y. Notice I'm replacing both. Negative, when you cube it, that's still a negative, right? That'll be a negative 2x to the third. Negative and negative, that's what? Positive x. I don't like to solve for negative y. So can we multiply everything by minus 1? So you'll have y equals, or change all the signs. And look right here, and look right here. Is that the same? That is an odd function. Some math books, actually, they'll say to you, the function is odd if f of negative x equals negative f of x. That's the same thing, really. Replace x with negative x and y with negative y. But they might write it like this. I'm not sure our book does. Our book says replace x with negative x and y with negative y. Bless you. And the last thing in this section, if you have two lines and you want to find out where they cross each other, finding points of intersection. If you have any questions, feel free. An example, let's say I have this graph here. Two graphs. One of them is, I don't know, I'll be a little cute with it. I'll call this x squared minus y equals 3. And the other one, I have this one, which is x minus y equals 1. And I want to find out where do they cross each other. From the picture, it looks like right here and right here. What is the x value and the y value? As I said, I was trying to be cute with this. I played with this. Notice the first one, which is x squared minus y equals 3. If you rewrite that, take the minus y to this side and the 3 to that side. When you change side, change sign. This becomes x squared minus 3 equals y. So you know that's a parabola, right? That's a parabola concave upward, smiley face. How do we know that? The coefficient of x squared, that's a positive number. It has a y-intercept of negative 3. This one here, again, I decide to play with them. Take the minus y to this side, take the 1 to that side, you'll have what? X minus 1 equals y. So I could have given it to you like this, which is a little bit nicer, but I decided to play with that. How do we know where they cross each other? Exactly, set them equal to each other. So since this is y and this is y, you set them equal to each other. And what we have now is a quadratic equation. Let's move everything to one side. When you bring the minus 1 to this side, it becomes a plus 1. That's a negative 2. I like factoring. I like solving a quadratic equation by factoring. Factor this one. X minus 2 times what? X plus 1. One of the easiest way to solve actually a quadratic equation is you move it to one side, factor completely, that's called solve by factoring, and you set each factor equal to 0 and you solve it. X will have to be 2 and x will have to be what? Negative 1. If you know x, can you find y? Sure, you can go to either one of these two equations. When x is 2, what is the y value? Take the 2 and plug it in. What is 2 minus 1? Is that a 1? So x is 2, y is 1. That's one of them. When x is a minus 1, what's the y value? What's a minus 1 minus another one? Minus 2. So I'm a little bit off with my picture. I should have came in a little bit more with it to have it intersect like steeper there or less there. But a 2 and 1 and negative 1 and 2. That's where they cross each other's.